So in the last lecture, as I said, that this particular thing k is equals to n pi by l, it holds inside it a lot of things. Okay. First thing that it holds inside itself is, remember the definition of k. So we said that k was root over of 2me by h cross. Okay. So this was the definition of k. So the moment we say that k is n pi, now try to understand that n is an integer. Okay. N is an integer, and this integer takes values from 1 to 3 4 dot 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 dot, because you can see here that sin kl is 0 only when kl is n pi, and that n has to be a positive integer, and that n starts from what? That n starts from 1 2 3 dot dot dot. Agreed? So k equals to n pi by l itself says that this side I can have 2m e by h cross. Okay, and there is a root over. This is equals to n pi by l. Now square both sides. So upon squaring both sides, you will get e. E is what? E is the energy of the electron, is equals to n square h square. So what is h cross? Remember, h cross is actually h by 2 pi. Okay, h by 2 pi. So this is E is equals to n square h square by 2 m l square. This miraculous result says that the energy of the electron which is confined in a box is discrete. It is no more continuous. For example, a free electron can assume any momentum and any energy. The moment you are confining the electron in a box, somehow the electron's energy is no more continuous, but it is discrete. This is quite something very amazing and very intriguing. Okay, so the energy is discrete. It means the electron is not going to stay in all the energy levels. Agreed? And you can see a very interesting result from here, that n is never zero. N is never zero. It means the minimum energy that the electron will have is with n equals to 1, that is h square by 2 ml square. So why this is amazing? It means that when you confine an electron in a box, the electron will never be at rest. From somewhere it will get this energy h square by 2 ml square from somewhere. Even if we don't give that energy, the electron will have this energy by birth. This particular energy is called as the 0 point energy. 0 point energy is not the energy that we have given. 0 point energy is the energy with which the electron is already there in the box. So somehow the electron, when you confine an electron in a box, it somehow attains a particular energy called as the 0 point energy. Even if you see, this 0 point energy is not the energy that we have given from outside. Okay, so consider an electron at rest. So consider the electron initially had an energy 0, and then what you did, you took this electron and you placed this electron inside a infinite potential. So this side you have an infinite potential, and this side also you have infinite potential. So the moment you take this electron and put it in a box, the electron from somewhere, God knows from somewhere it acquires a minimum energy, which is h square by 8 ml square, where m is the mass of electron and l is the length of the box. This energy is called as the 0 point energy, which is really a puzzle. From where the 0 point of energy is coming, we don't know. But somehow the electron has this energy the moment you confine it in a box. Agreed? So two most important things are, point number one is the energy for the electron is discrete. Okay, and point number two is there is something called as a 0 point energy with which the electron is always there with the in the box. From where this energy comes, we have no idea, but it comes. Agreed? Now let us look at the wave function. Okay, how the wave function actually looks. So if you go to our previous lecture, we stated that the final wave function after putting the condition 1 and 2 was psi is equals to a sine. So there was a kx, but what is k? Look at the right hand side. K is already n pi by l. So what I can write here? In place of k, I write n pi divided by l, and there was a x, so it is kx. So this is the wave function. But then the question is, what is a? Okay, and how to calculate this a? Then we will put one more constraint that is related to probability. We know that total probability is always 1. I mean, the particle has to be found somewhere in space. And we already defined probability as integration from minus infinity to infinity, psi star psi, okay, dx equals to 0, equals to 1. So this is our probability statement. In this case, we don't have space from minus infinity to infinity. We are dealing only with from 0 to L. So what do we do? So instead of writing the entire space from minus infinity to infinity, because we have to do nothing with minus infinity to infinity, because our particle is confined between 0 to L. So obviously the limit is from 0 to L. So this is the constraint that we will put on the wave function. Now this wave function that you found using Schrodinger equation, please see that this wave function is somehow related to probability. We have already discussed a lot of time what is the physical meaning of a wave function. So Schrodinger equation for the particle in a box gave us this wave function, and the interpretation of this wave function is only with probability, that is probability of finding the particle at different position. We'll come to that. So let us find the value of a first, and then we'll look at the probability later on. Now, so if you solve this, you have an integration 0 to L. Now what is psi star? Since psi is a real quantity, psi star will be equal to psi. So there will be 2 psi multiplied here. So there will be an a square. Okay, take it outside the integration, and we will be left with sine square n pi x divided by L into dx equals to 1. Agreed? Now this integration can be easily solved. How to solve the integration with sine square? Well, you convert it into cos terms. Okay, so I'm not doing those steps. I'm just writing the final result, and what you get, that implies when you do this integral, you find you'll get a square into a by 2, so into L by 2 equals to 1. This is what you will get. So what is a? So a is finally root over of 2 by L. Agreed? So by using the probability condition, we found the wave function. So what is the complete wave function after putting the value of a? So let me write it here. So since your a is root over of 2 by L, so the wave function is, the complete wave function is root over of 2 by L sine n pi x by a. Agreed? Sine n pi x by a. So now, okay, so we got the complete wave function that represents the particle in a box. Now we'll look at the probability. Keeping the main results, let me erase the board, keeping the main results. Okay, so two main results. One result is I have placed the wave function here, and second, the energy which are discrete has been placed here. Now what we'll do is we'll talk about the probability. Agreed? So let us look at the probability. So can you tell me what is the probability of the particle in the box? So between any region from x to x plus dx, okay, the probability will be psi square dx. So what is the probability? So that will be 2 by L, and this will be a sine square function. Interestingly, this will be a sine square n pi x by L, okay, so into dx. So now what you see is that probability is a sine square function. Probability is a sine square function. Now what we can do is we can put the probability values for various values of n. Okay, so let me bring the box here to emphasize some important points. So this is my particle in a box. Okay, now so let us look at the condition for n equals to 1. Okay, so for n equals to 1, what is the energy? For n equals to 1, the energy is, as you can see, I've written there, a square divided by 2 ml square. So this is the energy. Now, what is the probability? The probability is sine square n pi x by L. So for n equals to 1, you need to draw the graph of what? You need to draw the graph of sine square, not n, so your n is 1, so you'll have sine square pi x divided by L. Agreed? So what is the value of sine square? So if you say this is your n equals to 1, okay, then the probability is such that is like this. This is the graph for n equals to 1. Agreed? So what is so special about this n equals to 1? So we have something very much amazing about this n equals to 1 probability. So this n equals to 1 says that if you do the measurement of finding the electron in the box, then for the electron which is in a state of n equals to 1, most of the time the electron spends at the center of the box. Because as you can see from the diagram that the probability is higher at the center. So if I can draw the diagram in a neat manner. So the diagram is somewhere like this. Okay, so you can see that the probability of the finding the particle is highest at the center, and the probability goes down as we go towards the wall. It means for n equals to 1 state, the particle spends most of its time at the center of the box. Now, this is quite amazing. Okay, why does the electron spends most of the time at the center of the box? No reason, but the quantum mechanics is saying that the most of the time the electron is going to spend at the center of the box. Now who says that? This Schrodinger equation is saying that. How the Schrodinger equation is saying that? It is saying that through this particular wave function that you found in the probability. But the craziness does not end here. If you look the state n equals to 2, okay, so what is the energy? Obviously the energy is higher. Since the energy is higher, how much higher? Let us look. The energy is 4 times. So because n square is 4, so energy is 4 times higher than the ground state energy. So the ground state is what? The 0 point energy, that is 2 m L square. So energy is 4 times higher. Since the energy is higher, I want to draw my diagram somewhere around here. It does not mean the electron has gone up. Okay, that's a bad thing. It just means that the next energy is somewhere around at the top. It means if the electron is in a state of n equals to 2, then its energy is more. Now, what is now the probability function? The probability function will depend on sine square. So 2 pi x by L. Okay. Now, if you plot this function, then you will get something very crazy. You get the probability like this, then the probability drops to 0 here, and the probability increases and drops to 0 here. Why this is very much crazy? I agree that the probability drops to 0 on the sides because the electron will not be found in any case near the wall, at the wall, because at the wall there is no wave function because there is no particle. The particle won't reach the wall because the wave function is, because the potential is infinity. But how the hell the probability of finding the particle at the middle of the box is 0? This is quite amazing. It means the electron is never found at the center of the box. It means the electron is found on this side of the box, the electron is found on this side of the box, but the same electron is never found at the center. So what I want to state here is that how come the electron goes from one side to the other side without ever, so how come the electron goes from the one side to the other side without ever crossing the center of the box? It's not possible. How can a particle go from one side to the other side without crossing the center? It's not possible. But quantum mechanics says that this is happening, because quantum mechanics is saying at the center of the box for n equals to 2 state, the probability of finding the particle is 0. It means the electron was never there at the center of the box. The electron is never there at the center of the box. But still the electron is here and the electron is here on the other side of the center. It's quite crazy, right? It's quite crazy. In this manner, you can draw the probability for various n equals to 3, n equals to 4, and so on. Okay. Now you would say that, hey, you are not doing something with the time. Where is the time? Where is the time? That is only space part. So the time is here. Remember how the wave function is written for stationary state? For stationary state, as we discussed in our earlier case, the total wave function, which is a function of both space and time, can be written as a product of wave function that depends only on x, and the time part was actually the exponential part. I have already discussed this in the last lecture. So the time part will be e to the power minus I, the energy of the electron. So it will depend on the energy of the electron, E by h cross into t. Now why the time part is like exponential? Because it's a stationary state and the probability is independent of time. So if you do psi star x of t into psi of x of t, then you will see that this is what? This is the total probability. So the total probability will be mod of psi of x square, and it is independent of time. It has to be, because particle in a box is a stationary state problem. Okay. So the total wave function is written in this manner. So this is the total wave function for particle in a box. Just the time part remains in the exponential. Agreed? And what is psi of x? Psi of x is your this, that is root over of 2 by L sine n pi x by L. Now you would ask, okay, so for n equals to 1 state, what I have done is I just draw the graph. I drew the graph, but mathematically I can calculate something. Okay, what I'll calculate? I'll calculate the expectation value of x. Okay, so for n equals to 1, can you tell me what is the expectation value of x? Expectation value of x means where the electron is found most of the time. So for n equals to 1, the expectation value of x is what? Is L by 2, because you can look at it from the graph. But in the next lecture, we will do this mathematically. Okay, why I'm doing this? The reason I'm doing all the mathematics and the diagrams is I want to tell you that the entire mathematical framework of quantum mechanics is correct. Your intuition, I mean not the classical intuition, but the intuition provided by the graph and the intuition and the mathematics, they concur with each other. Agreed. So what I'll show you in the next lecture is that, so you drew the graph of the probability here for n equals to 1, and I said by looking at the graph that the most of the time the electron somehow spends at the center. Now this thing that I predicted from the graph, I want to show you mathematically. Mathematically what I'll do is for n equals to 1, I will calculate the expectation value of x by using the quantum theory and all the tools that we have developed in our theory. And I'll show you that this expectation value of x. So what is expectation value of x? At what position of x you are expecting the particle to be found most of the time. And from the graph we predicted that most of the time for n equals to 1 state the electron is in between, in the middle of the box, that is L by 2. And mathematically in the next lecture I'll show you that the expectation value of x is L by 2 for n equals to 1 state. So we'll do that in the next lecture.